So how much memory an average Java EE application server consumes? It is an interesting question to know if you would like to use the application servers in microservices context. And what I would like to do is to launch the most popular application servers within a Docker and measure the memory usage of the application server with the JVM and even the whole Docker image, so even the operating system. And I will use the project DocLens. Is a set of Docker files, simplistic Docker files, which allows you to run common application servers within Docker image. So it's the project DocLens. And also what I will do, I will use the ping application. It's a simplistic 9 kilobyte WAR, which checks the health of the application servers, like a pinging the image. Then let's start, and I would actually start with Hello World Java 8 NAS one application to set the as a reference to see the overhead of a simplistic Java application in comparison to Java EE application server. So I would just run it with docker -d for detach -p 4242 is the stock port. And the image, I would like to use proper name, and nano micro, and the name of the image is nano micro, and I need to run. Docker ps, perfect, is running. It was started 2 seconds ago. So let's see whether it actually works. I would like to launch it. Micro ISO yesterday, so it seems to work. This is the image. So now let's see. I will use the docker stats command. And it uses 63 megabyte of RAM. So I will just check it again. So I will just use this. And again, around 65 megabyte of RAM. So okay, this is just the reference. Now let's go ahead and launch the Webs for Liberty profile Java 7 edition. So I would use the ping here again, and would like to use the run script, which basically just starts the WebSphere on port 9080. This is actually what happens behind the scenes. Docker ps. So WebSphere is running. So I would like to test it. 9080 was it, I think. So this is the Liberty profile, and ping was the is the application. So let's ping it. So it answers, and we can also get the memory stats. So now check the overhead. Docker starts WLP ping. And it consumes 160 megabyte of RAM. So I would say it is twice as much or even 3 times as much. So the overhead is around 100 megabyte of RAM. So the difference between WebSphere Liberty profile and the Nano Micro is around, so we can just repeat this one. And this is 70. So it really depends what the memory pressure on the garbage collector is, so how often the garbage collector runs, so it will also influence the memory utilization or memory use. Okay, now go ahead and to Whitefly. And let's start the Whitefly ping app, Docker ps. Whitefly, it runs on 8282 port. So I would like go here and 8282 ping. So it's running. So we can check the boot time. So it's running, and Docker. Check the statistics. Whitefly ping. And it is a lot. It uses around 600 megabyte of RAM, so 550 megabyte more than Hello World Java. But let's go ahead and see what happens within the container. Whitefly ping. And we see the deployment and the whole start. And what's interesting here is the Wildfire was started with out-of-the-box settings -XMS 2 gig and -XMX 2 gig, what basically means, you know, acquire all the memory. So what is surprising that it still only consumes 600 megabyte of RAM. So without the settings, the overhead would be very similar to WebSphere. So if you really are interested in a small memory footprint, check the -XMX and -XMS settings of the JVM. Okay, so Wildfire is running. Now go ahead and try Tommy. And docker run -d -p. Now let's use different port 8080. It was airhex Tommy ping docker ps. And what I forgot to give a Tommy a nice name, and therefore we got a random name Happy Borg, which is nice. So docker starts Happy Borg, and it uses 260 megabyte of RAM. And let's see whether Tommy is running. Actually 8484, and we see here the Tommy. So this is the Tommy page. So it looks good. So, okay, we got the Tommy. So we have already several application servers running. So go with the next one and try Payara ping, and run it. So where is it? Payara is running. Port is stock 8080. So go into 8080. So looks like Payara, and we have here the output. So it looks good, and docker starts Payara ping. So 750 megabyte of RAM. So it's the worst possible case right now. So why it's so high? And the reason for this runs on as a sample I used during the Java EE microservices workshop, and it is configured, and this is the configuration. So it uses also this 2 gig settings here, and it seems like it uses it more aggressively than Wildfire. So it is -XMS and -XMX of 2 gig both. Okay, now we saw Payara. Now let's go to the very last one, and this is the WebLogic, the recent one. And I would like to run it as well. Docker ps, and this is the WLS, the WebLogic. Name of the container is WLS ping. So docker starts WLS ping. And it actually consumes 500 megabyte of RAM. Again, is probably caused by the JVM settings. Let's now double check that. Docker logs WLS ping. And at start, there should be somewhere the -XMS settings. It's hard to spot. -server -XMX. It is 512, and MS it's 512. So the WebLogic used the 512 -XMX and -XMS settings. So, and therefore it is around 512 max. So so what we learned actually is that the overhead between a plain Java image, which was the Hello World one-liner NAS one, and the application servers is in worst case around 500 megabyte of RAM. And so we have here, you see 60 megabyte was Hello World Java, and 500 megabyte was a full-fledged Java 7 capable application server. But the Nano Micro was deployed without any -XMX settings, and all other application server came with the vendor defaults. So this is the actual overhead. And what's interesting to know, if you will start the application server multiple times because of Docker optimization, it is not like you will replicate the overhead over and over again. So thank you for watching. Enjoy Java EE and microservices, and see you in one of upcoming conferences, projects, AirHacks at Munich Airport, or even the online version AirHacks.io, where I recorded already Bootstrap effective testing and the Java EE microservices workshops.